So I called this lesson 0 because in theory this should all be review. So I'm going to go quick. Review of trigonometry. Find the length of the missing side. How could I find the length of the missing side in that triangle, in that right angle triangle, if I know 2 of the sides? Pardon me? Pythagoras. To do this, we use Pythagoras. One of the easier formulas to memorize out there. I think I did give it to you on your formula sheet, even though I shouldn't have to. The reason it's nice is it's alphabetical. It's traditionally written as a squared plus b squared equals c squared, except there's one key thing. The only key thing that you have to remember about Pythagoras, what does that side have to be? It's got to be the hypotenuse. So in our equation here, we would say 55 squared plus x squared equals 73 squared. Yes? And we've done so much formula manipulation now. Let's get the x by itself. What would I do to get the x by itself? What's the first thing that I would do? Subtract what? You're right. The 55 squared, and then I have x squared. How to get rid of a squared? I have no problem, Matt, if you go straight to going like this. It's going to be a square root of 73 squared plus 55 squared. Mr. Dueck, doesn't that just mean that the squares will cancel? Isn't that 73? Oh, minus, Mr. Dueck, not plus. Nice try. Thank you, Matt. You did say minus. Can't I just go 73 minus 55? Let's find out. Let's find out. Is that the same as, well, I can do the right hand in my head. What is 10 take away 9? Okay, so that works out to a 1. What's 10 squared? 100. What's 9 squared? 81. What's 100 take away 80? This works out to the square root of 19. Is the square root of 19 the same as 1? Can you just cancel the squareds and the square root when there's more than one term and you're subtracting or adding? No. You have to do what's inside the brackets first. So it's going to be 73 squared minus 55 squared. I don't think this will work out evenly, although it might by a fluke. And then I'll go, oh, this might work out evenly. Square root. Holy smokes, it did. 48 centimeters. You'll notice for the square roots, I tend to type what's inside the square root first, hit equals, and then go square root answer. Mainly because on my calculator, as soon as I hit a square root, it automatically does an open bracket. And then having multiple open brackets, it gets confusing for me. So whatever. Good. Try example 2 on your own. I'll do it up here. Let's see if we get the same thing. Is that right? Yeah. When do you guys, because I haven't taught the younger grades, when do you first see Pythagoras? Do they do it in grade 8? Do it in grade 9? You don't do it in grade 8? See, Elijah, you did it in grade 9? And grade 10? What grade are you in now? Mr. Dueck, yes, Elijah. I've been doing this for a few years. Yeah, good point. Would you be really grumpy if I can just do that, Mr. Dueck, all on my calculator and go straight to the answer, showing no work whatsoever? I'm okay with that. Riley, would I ever do that on a test or a quiz? No, I'm going to, dumb mistakes and all that. But if you're good enough to do Pythagoras all on your calculator, assuming you have a half-decent calculator, you know what? You're in year 3 of Pythagoras. I'm okay with it. Oh, if you're getting it wrong consistently, then Tanisha, you better show some work, right? Example 3. Find x, find y. Huh. Hmm. 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 Hey! Did you hear the brilliance coming off to my right, your left? He said, find x for, this is 2 triangles in ones. So, Matt, what you're really saying is this. Dueck? Yes. Find x first. Is that what you're saying? Hey, try doing it all on your calculator, showing no work whatsoever. Tell me what x is. I think it's going to be 17 squared, take away 15 squared, square root. And I think this might work out evenly and might get to 8. 8 what? Oh, no units this time. So now what I have is this. And 20, yes? Hey, try it again. 25? Hey, Mr. Dueck, you did that completely in your head without a calculator. I cheated. There's a few Pythagoras triangles that I have memorized, and I can usually find them hidden if they work out evenly. Riley, when math teachers are making up Pythagoras, we'll often use the 3, 4, 5 triangle. What's 3 times 5, Riley? What's 4 times 5? 5 times 5. That's, if you're wondering how I did that one in my head, I recognized it was the 3, 4, 5 triangle in disguise. And I can remember 3, 4, 5 triangle because they're in order. There is also an 8, 15, 17 triangle, and there's also a 5, 12, 13 triangle if we're trying to make stuff work out evenly. But you know what? I won't always do that. So Pythagoras, tool number 1. And again, Curtis, if you're so good at Pythagoras, I mean, you're in year 3 basically of it, you can do it all on your calculator. In your homework, I will assume that you didn't just copy out the answer, knock yourself out. But, yeah, getting wrong on the tests and the quizzes, well, then I'll freak in a nice loving teacher kind of way. Then we broadened this idea. We said every triangle has 3 sides, and if I give you an angle inside the triangle, we can label those sides as opposite, adjacent, and hypotenuse, although it depends which angle I gave you. The hypotenuse always stayed the hypotenuse, but opposite and adjacent could flip-flop. So, here's my angle. Traditionally, we use the letter theta for an angle. Why? Well, in math, there's all sorts of shorthand. We like to use certain letters. For example, if I use x and y, I generally assume I'm talking about a graph. Why? Because x and y are graph paper. If I ever see a theta, even if you don't tell me where it came from, I assume it was an angle. If I see the letter r, I tend to assume it came from a radius. There's all sorts of little shorthand like that. So theta, 0 wearing a belt, if you want to think of it that way. This side, oh, this long side, opposite, adjacent, or hypotenuse. Put an H there. The second longest side in this triangle, the next one, this top one, opposite or adjacent. By the way, here's another way to remember it. Right now, Callum and I are facing each other. Do you know what another word for facing each other is? We are sitting opposite. This side is facing that angle. It's opposite. It kind of makes sense in English. What's this side right here then? What does the word adjacent mean in English? Connor and Callum are adjacent to each other. It means beside. It's the one touching the angle, but not the hypotenuse. We also have 3 primary, oh, by the way, what if we were talking about that angle? This would still be hypotenuse, but that would be opposite, yes? And that would be adjacent. We also have 3 primary trig ratios. What are they called? That's the acronym. What's the first one called? Sin is when you swear in my class or forget your calculator. That's a sin. That's not the trig ratio. Sine is the first one. It's written S-I-N, but it's pronounced sine. It's a sin when you say sin instead of sine. What's the next one? Cosine, abbreviated cos. Tangent, abbreviated tan. Mr. Dueck, you said 3 primary trig ratios. Are there other ones? Yep. There's secant, cosecant, and cotangent, which if you take Math 12, you'll learn about. Or are you guys, it might be part of Math 11 now. Is it part of the new Math 11 curriculum? Have you guys done secant, cosecant, and cotangent? You haven't gotten to trig yet? Okay. So, in Math 11? Okay, there you go. And here's the beautiful thing. Your calculator has all of the sines and cosines and tangents programmed in. Evaluate the following to 4 decimal places on your calculator. Find the sine of 42. I better make sure I'm in degrees. I am. 0.6691. Find the cos of 76, the tan of 45, and the tan of 90. Do that really quickly. One of them should be strange. Tan of 90? Undefined. Hey, do me a favor. Find the tangent of 89 degrees. What do you get? 57? Find the tangent of 89.99. Let's see if we can sneak up to 90 and make a guess. What do you get? How about 89 point and 4 nines? So 89.9999. What do you get? Bigger yet? Oh, bigger yet? So the closer you get to 90, the bigger the tangent value gets. In fact, another way in calculus, you might say that the tangent of 90 degrees approaches infinity. As a graph, it shoots off straight off the page right when you get to 90 degrees if you're ever graphing tangent. For what it's worth. Little Math 12. Oh, we can also use our calculator to go backwards. John, not only if I know the angle can I tell you the sine or the cosine or the tangent, I can give you the tangent decimal or the sine decimal or the cosine decimal and say to my calculator, hey, what angle did it come from? So if the tangent of theta equals 3.732, then theta equals, how do you do that on your calculators? Do you remember? All of you somewhere, probably right here in the top left corner, have either a second function button or an inverse button or a shift button, or I think that's all I've ever seen it called. What you do is you can go inverse or second function tangent, and your calculator may put an inverse symbol, which in Math 11 you may have learned this year is a little -1, of 3.732. And if you hit enter, you should get 74.999. Now, depending on how crappy your calculator is, some of you may go second function tangent 3.732 equals. Some of you may have to go 3.732 second function tangent. I hate those calculators, but figure out which one yours is, figure out how yours works, and make sure you can get the, by the way, 74.9998, what is that really? What angle did I start with here? Hakeem? 75. Really? Was that such a big leap for some of you? You're like, what? I started with 75 and I rounded off, right? So, going backwards, If I tell you, solve the following to the nearest degree. If I tell you the sine of A is 0.5, tell me what angle A is. If I tell you the cosine of theta is 0.5, tell me what theta is. And if I tell you the tangent of theta is 0.4877, tell me what theta is. I know this one. I know this one. I think. Yeah. I don't know this one. You get 30 degrees, 60 degrees, and 26 degrees? The 0.5s in Math 12, you often end up memorizing them because they show up so often. So I was able to do those ones in my head because I got them memorized. I know sine of 30 is 0.5. I know cosine of 60 is 0.5. No yawning. Turn the page. Here is the word that some of you blurted out. It's a great little acronym. SOHCAHTOA, which tells us the definitions of each trig ratio. It tells us that sine is defined as the length of the opposite side divided by the length of the hypotenuse. It says that cosine is defined as the length of the adjacent side divided by the length of the hypotenuse. It says that tangent is defined as the length of the opposite side divided by the length of the adjacent side. Because of that, and combining the fact, McKenna, that we have all of these values stored in our calculator, we can now solve triangles. Example 6. It says, determine the length of the indicated side to the nearest, whatever I said. Okay. Can I use Pythagoras? No, not yet. Nope. I need two sides, okay? But that's another tool in our arsenal. They gave me one angle and one side, and so I'm going to label the sides. But listen closely. This is where I may contradict your grade 10 or grade 9 teacher. I never label all three sides. I think that's dumb and a waste of time. All I label are the two sides that have stuff on them. So you ready? Here's my angle. This x, opposite, adjacent, or hypotenuse. The 15, adjacent, or hypotenuse. And this is where I would argue, I've seen some teachers and they say, oh, and label that with an A. I think, first of all, that's a waste of time. Secondly, I think that makes it tougher. By having an O and H, and that's it, isn't it screaming out that which one has the O and the H in it? Sine, cosine, or tangent? Isn't it more obvious that it's sine? Where if you put an A there, don't you now have to ignore the A, focus on the O and the H, and say, those are the ones that why? Doing more work to make it more confusing? I never understood that. Now, maybe there's a good reason. I need to talk to some of my colleagues and see why they teach it that way, but that has always been a pet peeve of mine that's driven me crazy. Why would you label all three sides? Label it two. Which trig function? Sine of what? What goes next to the trig function? The angle, always. Always the angle. Always the angle. What's the angle? Equals opposite over hypotenuse. How would I get the x by itself? What would I do with that 15? X is going to be 15 sine 57. By the way, look up for 1 second. Don't write this down. Don't write this down, but look up. Be cautious in typing that on your calculator, because I don't know whether your calculator is going to go 57 times 15 first and then take the sine of that, or do the sine and then times 15. And there's an easy way around it. Always put the number, the coefficient, in front of the trig function and the angle inside the trig function. So never, ever write stuff like that, just because I don't know how your calculator works. It's going to be 15 sine 57. 12 point, did I say it at 2 decimal places or 1 decimal place? 12.6. Units? Yoink. B. The 11.1, opposite, adjacent, or hypotenuse? The 11.1 is adjacent? How do you know? Adjacent is beside, would be touching. It's not. Oh, and that was not the hypotenuse. That's the one I'm going to leave blank. Opposite. Adjacent. Which trig function? Tan of what? What always goes next to the trig function? The angle. What's the angle? Opposite over adjacent. How do I get the x by itself here? If you do that, I can now cross multiply. Yes, you are right, Tanisha. By the way, most of you don't bother putting that over 1. You just kind of see it in your head, but you're right. I think if I rewrite this, Tanisha, I'll get x times the tan of 28 equals 11.1 times 1, which is just 11.1. How to get the x by itself? Divide. Which one? Divide. X is going to be 11.7 11.1 divided by tan of 28. Mr. Dueck, if I can be fairly comfortable doing these showing less work or almost in my head, you know what? I'm good with that on your homework if you can do a lot of trig just going to your calculator. $20.9. Being completely honest, generally when I do trig SOHCAHTOA, I write this statement right here, and I can go straight to the answer because I've learned that when the x is on the bottom, it moves over here and the tangent moves down there, and I end up dividing. When the x is on the top, it's just multiply. I've just done so much trig. There is a pattern. Is it 20.9? Yeah. Hey, not only can you find a missing side, you can find a missing angle. It says, determine the measure of the indicated angle. I guess in example A, they want me to find angle X. Dylan, I tend to put a little hash mark on the angle just to emphasize it. That's our angle. You can even, if you want to, color it in. Yay! That 15, opposite, adjacent, or hypotenuse? Matt, I agree. That 7, opposite or adjacent? Which trig function has the a and the h in it? Cosine? Ooh, what always goes next to the trig function? The angle. What's the angle here? It's a variable. X equals adjacent over hypotenuse. And I'm going to suggest to you now that that question, the way I've written it, looks exactly like these ones here, except I put a decimal instead of a fraction. So, how do I find an angle? How do we find an angle? Inverse second function. How do we write this? Ready? Draw a little arrow. That's the symbol for angle. X equals. Now, if you go straight to the answer, that's fine. But if you're in a situation where a teacher requires you to show work, you go like this. That's the symbol for inverse, which is why on your sine and cosine and tangent buttons right above it in small writing, that's what it says, because it's saying that's what the second function, the shift thing is. To type that, we go like this. How do we find an angle? How do we find an angle? Inverse. So second function, inverse cos, bracket. 7 divided by 15, close bracket, because that's how you write 7 over 15. Or if you have a cheaper calculator, you may have to go 7 divided by 15, press equals, and then go second function cos of that. And I hate those calculators. What angle? 62, did I say to the nearest degree or to the nearest tenth of a degree? Nearest degree? 62 degrees. 62 degrees. B. I guess they want me to find angle Y. Okay. That 8.1, opposite, adjacent, or hypotenuse? Opposite. The 14.5. Which trig function has an OH in it? Sine. What always goes next to the trig function? The angle. That equals opposite over hypotenuse. Second function, sine 8.1 divided by 14.5, 14.5, all in brackets because it's that whole thing, the inverse sine of that. 33.96, I think it's supposed to be 34 degrees, yes? Oh, and you'll notice this time I wasn't so fussy, I didn't bother showing this little inverse cos. You can. And I'm just showing you that in case you ever do have a teacher who's insistent on saying, show me what you did. Me, as far as I'm concerned, if I see that line there and the answer, that's plenty. Pardon me? I haven't gone there. Patience, young grasshopper. That's the end of the lesson. Now, I think you have some homework attached, yes? Yeah? Hey, what's your homework that you'll need to hand in because it's homework? Number 1, 2, 3. I think it's going to be all. Yeah, I'm good with 4. I'm good with 5. Good with 6. Word problems. I haven't talked about them yet, but see if you can figure them out. 7 and 8. And the answers are attached.
What about the tougher questions?
What about you have tougher questions?
Yeah, Amazon. Part 2 tougher questions.
You have oh! Ha! I should continue scrolling. Part 2, tougher questions. Of course! Try number 1 and number 2. Thank you. I almost forgot to assign that. Make sure you thank Connor for reminding me to assign that. I would have missed out on that foolishly, and that would have, probably hindered your learning experience, I think. Folks, you got 45 minutes. First thing you really want to make sure you get done is the take-home quiz. Get that done in class. And then if you don't have all the trig homework done for Tuesday, I won't freak out. But by the following week, once we come back after your test and after the long weekend. Trig. Can't live with it? Yes, you can. Good stuff.